Welcome back to Spring into Math 7. I'm Mrs. Campbell, and today we're going to be doing the second part of our lesson on finding the surface area of cylinders. Okay, so when we left off last time, we were talking about using formula to find the surface area of cylinders, and I wanted to take a look at some examples. So here we go. Here's our example. In this cylinder, the radius is 7 inches, and the height is 14 inches. Okay, so we simply put these numbers into the formula and solve for the surface area. Remember, our formula was surface area equals 2 pi r squared plus 2 times pi times the radius times height. Okay, so we just plug in the numbers. There's our 7, 7, 14. So we get 2 pi times 7 squared plus 2 pi times 7 times 14. 7 squared is 49. 7 times 14 is 98, so we get surface area equals 2 pi times 49 plus 2 pi times 98, which once we do 2 times 49, we get 98, and 2 times 98 is 196. So we have 98 pi plus 196 pi, so the surface area is then 294 pi. And when we multiply it by pi, we find that the surface area is 923.16 square inches. Okay, sometimes we may be given the surface area of a cylinder and be asked to find its height. So if we do this, we simply fill in the information we know into the surface area formula. So this time, instead of solving for surface area, we're going to be solving for h, the height of the cylinder. Okay, let's look at an example. The surface area of a cylinder with a radius of 3 inches is 78 pi square inches. What's the height of the cylinder? All right. Well, we know that the radius of the cylinder is 3 inches, and we know that the surface area of the cylinder is 78 pi square inches. Now, sometimes a problem will include pi in the amount because it's more precise. Now, we'll see that this also makes our calculations a little bit easier. So all we have to do is put 78 pi into the formula in the place of surface area at the beginning of the formula, and then we can use the formula to solve for the height, or h. So we have surface area equals 2 pi r squared plus 2 pi radius times height. I'm just going to plug our numbers in. This time we know the surface area being 78 pi. Plug in the rest of the numbers. We get 78 pi equals 2 pi times 3 squared plus 2 pi 3 times height. All right, 3 squared is 9. 2 times 3 is 6. So now we have 78 pi equals 2 pi times 9. Plus 6 pi times height. 2 times 9 is 18, so now we have 78 pi equals 18 pi plus 6 pi times height. And this time we're going to subtract 18 from both sides. We get 78 pi minus 18 pi equals 6 pi times height, which gives us, once we subtract 18 from 78, we get 60 pi equals 6 pi times height. And we now have, as we continue our calculations, we're going to divide both sides by 6 pi. So now we have 60 pi divided by 6 pi equals height. We get 10 inches equals a height. So this cylinder has a height of 10 inches. And we can check our work by putting the height into the formula and solving for surface area. All right, so we've learned 2 ways to find the surface area. Let me highlight them for you. Drawing a net and using a formula. We can use either of these methods to solve word problems. Yes, the famous word problems that involve surface area. Now, nets may be useful if the problem doesn't give you an image of the cylinder. So let's look at this example. Mrs. Johnson is wrapping a cylindrical package in brown paper so she can mail it to her son. The package is 22 centimeters tall and 11 centimeters across. How much paper will she need to cover the package? All right, now the problem tells us the height and the diameter of the cylinder, so let's use the formula this time for finding surface area. Now be careful. I'll highlight this. We have been given the diameter, not the radius. Don't let that trip you up. That might happen sometimes. So we need to divide it by 2 to find the radius. 11 divided by 2 is 5.5. And now we have the radius and the height, so we can put these in for the appropriate variables in the formula. And then we just plug them in. Surface area. Here's our formula. Surface area equals 2 pi r squared plus 2 pi rh. Surface area equals 2 pi times 5.5 squared, radius squared, plus 2 pi radius times height, which is 22, which gives us 2 pi times 30.25 plus 2 pi times 121. 2 times 30.25 is 60.5. Pi plus 242 pi. I just multiplied 121 by 2. And then surface area is 302.5 pi. Multiply that by pi, and we get 949.85 square centimeters. So we know that Mrs. Johnson will need 949.85 square centimeters of brown paper to wrap the entire package. All right, last example. Travis is making lanterns by covering glasses in colored paper. Each glass has a radius of 2 inches and a height of 6.5 inches. If he covers the sides and the bottom, pay attention, the sides and the bottom, notice not the top, of 6 glasses, again, you want to pay attention to that, 6 glasses, how many square inches of paper will he need? I've given you very particular notes here and tips. Read the problem carefully. It's asking us to find the surface area of only the bottom face and side of the cylinder, not the top. Again, because that's a lantern, you wouldn't want a top on it, okay? So notice that we need to find out how much paper he's going to need for 6 glasses. That's another important piece of this problem. So it is more complicated, so it might help to draw a net. In your drawing, you're going to want to shade the parts that are going to be covered in paper, the bottom of the glass and the side, and then the diagram in the next slide has all the sides shaded. Which part of the net should you remove the shading from to make sure it's correct? Well, like we talked about, it would be on the top. We're not going to be doing this one because we don't want to top on our lantern. It would catch on fire. All right, so with a net, we can clearly see which face represents the bottom and which represents the unpapered top. So now let's fill in all the measurements and solve for the area of the bottom and the side of the glass. Okay, look at the bottom first. The bottom area of a circle, pi r squared. The radius is 2, so we just square 2. We get area equals 4 times pi. So the area is going to be 12.56 inches squared. Now the area of the side will be 2 times pi times the radius times the height, or 2 pi times 2 times 6.5. 2 times 6.5 is 13, so 2 pi times 13. So the area is 26 pi, or the area will be 81.64 square inches. So now we add the area of each component. That's important. Add the area of each component to find the total surface area that Travis will cover with paper, the side and the bottom of the glass. So the bottom will require 12.56 square inches. The side will require 81.64 square inches. So we add those together, we get a grand total of 94.2 inches squared. Now remember, one glass, that only covers one glass, makes one lantern. The problem asked us to find how much he's going to need for 6 of them. So this is kind of the easy part. All we have to do is multiply it by 6. So we have 94.2 inches squared times 6 gives us 565.2 inches squared. So he will need 565.2 square inches of paper for 6 lanterns. All right, everyone, that just about does it for this lesson. Thanks for joining us, and we'll see you next time. Bye-bye.